Hi everyone, this is Dr. Nak. We're going to go over section 10.1. The title is Finding Composite and Inverse Functions. Let's first go with the composite functions. Then we'll study inverse functions. So what the heck are composite functions? Well, a composition of functions is when one function is inside of another function. So I drew you a picture here. So basically this is what's going to happen. So we're going to input our x value into the function g. And the output is going to be g of x. Now what we're going to do with that g of x is that we're going to have to input that into a function f. And the output is denoted by f of g of x. Now the notation for f of g of x is this. But it's also written as f of, it's a circle, g of x. Also, please note that this does not equal to f times g of x, by the way. Okay, so let's take a look at an example with this picture. Suppose our function g of x is defined as a square root of x, and our f of x is defined as x cubed plus 1. So what's going to happen is x is going to go inside of g. So the output is going to be square root of x. So let me just write. So x is going to go inside of g. So this is going to be the input. Now the output under g of x is going to be square root of x. Now what we're going to do is we're going to take that square root of x and plug that into f of x. So basically, I'm going to take the square root of x, and then I'm going to plug it into our f of x. So that means you're going to have to replace this x with square root of x. So what is the expression that we're going to get out of that? Well, it's going to be, let me see, where can I write this? I'm going to write it over here. So this is going to be square root of x to the third plus 1. So this is precisely our f of g of x. Don't panic. We're going to do a bunch of examples, especially for this section. Okay, so let's give a formal definition for the composition of functions. So the composition of two functions, f and g, is written f circle g and is defined by f of g of x equals f of g of x. Okay, when I just said that, it sounded exactly the same, but do you see the difference in notations? And let me just write down, we read this as f of g of x. Let's do some examples. Okay, example number 1, let f of x to be 4x minus 3 and g of x be 2x plus 7. Find f of g of x. So let me just first start out with this formal definition. So I'm going to start out with f of g of x. And the notation for that is f of g of x. So g of x becomes the argument of f of x. Alright, so now next step is this. This is how I usually do it. Now, next step, replace your g of x with the given function. Well, g of x is 2x plus 7. Alright, so I'm going to rewrite this as f of 2x plus 7. Now, from here, look at the function f of x and replace his x with what's in the parentheses. So meaning, let me see. This is one quantity, 2x plus 7. Now f of that, what you need to do is you need to plug the entire 2x plus 7 into this x. So that means you're going to have to replace this x with 2x plus 7. You guys with me? So now I'm going to rewrite this as 4 times 2x plus 7 and then minus 3. So this is what we plugged in place of x. So that's going to be our answer, but let me just simplify a little bit. So this is going to be 8x plus 28 minus 3. So our answer is 8x and then plus 25. So let me just box that. Now, if you're still wondering how in the heck did that just happen, think of it in this way. So let me just, this has nothing to do with this problem, but let's take a look at this. So suppose you're given that f of x is 4x minus 3, just like our f of x, that's given. Now, how do you compute f of 2, let's just say? Well, f of 2, you're going to replace x with the 2 and then follow the same format of f of x. So in this case, 4 times 2 is 8. 8 minus 3 is 5. Okay, now let's take a look at f of, I don't know, maybe negative 5 or something like that. Then this is going to be 4 times negative 5 and then minus 3. All right, so this is going to be negative 20 minus 3, so that's negative 23. Okay, so now f of, let's go with the happy face. Okay, so you're gonna replace our x with the happy face and then minus 3. You're like, what in the world is this, right? So now let's take a look at, well, make the happy face to be 2x plus 7. Okay, so this is the happy face. So how does it work? So this is 4 times the happy face, but my happy face is entire 4x plus 7. I mean, not 4x, sorry, 2x plus 7, and then minus the 3. That's how exactly what we get right here. Let's take a look at more examples. So example 2, find g of, just kidding, f of g of x, then g of f of x, and the last one is f times g of x. So let's first go with A. F of x is 6x minus 5 and g of x is 3x plus 1. So let's first go with f of g of x. So f of g of x, this is written as f of g of x. Next step, I'm going to replace our g of x with the given function, which is 3x plus 1. Now this is telling you that look at function f of x and replace its x with what's in the parentheses. So basically, here's the happy face, or just think of one quantity, and you're going to plug this basically into here. So what we're going to get is 6 times 3x plus 1, and then minus 5. Now from here, I think we got this. So this is going to be distributing the 6. It's going to get 18x plus 6 minus 5. So it looks like our answer is going to be 18x and then plus 1. Okay, so now let's look at g of f of x. Okay, so we write this as g of f of x. So now, next step, what we need to do is we need to replace our f of x with the given function. So we get g of f of x is defined by 6x minus 5. All right, we're going to do the same thing now. So this is telling you, look at function g, replace its x with what's in the parentheses. So now what we're going to do is we're going to take this guy and then plug this into, sorry, I'm just going to go over here, plug it into here. That's what it's telling you to do. So what do we get? We're going to have 3 times 6x minus 5 and then plus 1. So let's keep simplifying this. So harder part is done. Now all you got to do is just simplify. So here what do we get? 18x and then minus 15 and then plus 1. So it looks like 18x and then minus 14. How you guys doing? Hopefully you're getting the hang of it. Alright, now let's do f times g of x. You'll realize that f times g of x is going to be completely different from f of g of x. So let's go with f times g of x. So this means you multiply 6x minus 5 and then 3x plus 1. So we're going to have to FOIL. So Here, first term is going to be what? 18x squared, and then 6x minus 15x, and then minus 5. So this is going to be 18x squared minus 9x, and then minus 5. Notice that our answer is completely different from f of g of x. So please be careful when you're computing f of g and then f times g. Let's do another example, part B. Let f of x to be 3 times the square root of x, and g of x is 2x squared minus 3x. Okay, so let's first go with f of g of x. So this is f of g of x. Next step, replace the g of x with the expression of 2x squared minus 3x. Alright, so now what we need to do is look at function f of x and replace its x with what's in the parentheses. So again, I'm going to take this whole ugly looking expression and I'm just going to plug it into here. So then what we're going to get is 3 times the square root of 2x squared minus the 3x. And let's just keep that as our answer. Okay, now let's take a look at g of f of x. So we get g of f of x. So this is g of f of x. Okay, step number 1, replace our f of x with, what's our f of x? 3 square root of x. Okay, now we're going to do the same thing. This is telling you now, look at function g, replace its x with what's in the parentheses. Okay, so let's stare at g of x. Now you need to replace 3 square root of x. Everywhere you're going to see the x. So basically you're going to have to replace it here and then also replace it in there. Alright, so this is going to be 2 times, don't forget the parentheses, 3 square root of x squared minus 3 times 3 square root of x. So this is going to give us 2 times, I'm going to do this step by step by step. Now the exponent rule says what? You're going to have 3 squared times the square root of x squared. That's this portion here. Okay, and then minus 9 times the square root of x. I'm just multiplying 3 times 3. So it looks like our answer is going to be 2 times 9. Now square root of x to the second power is going to give us x, and then minus 9 square root of x. So here you're going to get 18x minus 9 square root of x. Can't simplify much of it unless you factor the 9 out, but you don't have to. So here's the answer. Okay, now let's take a look at f times g of x. So this is going to be 3 square root of x multiplying here by the whole quantity, 2x squared minus the 3x. So next step, what we're going to be doing is we're going to be distributing this to each term here. So you're going to have 3 times the square root of x times 2 times x squared minus 3 times the square root of x multiplying here by 3 times x. I'm trying to do this step by step. Now how do you simplify this? Well, 3 times 2 is what? 6. And then you're going to have square root of x times x squared. And then minus 3 times 3 is 9. We're going to have 9 times the square root of x multiplying here by x. Now, since we have not gone over how to simplify the radicals just quite yet, so you can leave your answer like this. I'm so sorry. I just made this problem up. So it kind of looks ugly, but those of you who knows a little bit more about exponents, square root of x is same thing as x to the 1/2 power. So if you want to go one more step, that's fine. So let me just write this as 6 times x to the 1/2 times x squared minus 9 times x to the 1/2 multiplying here by x. Now, what do we do with those exponents? Well, you add them, because remember this property, if you have x to the m times x to the n, you add exponents. This is going to be x to the m plus n. So here what we're going to get is 6 times x to the 1/2 plus 2, but 2 is same thing as 4 over 2, and then minus 9 times x to the 1/2 plus 1, but 1 is same thing as 2 over 2. So here what we're going to get is 6x to the 5/2, and then minus 9 times x to the, what is that, 3/2. Okay, sorry, I just simplified all the way, and then you can convert back into a radical, but by the time you're listening to this, you're like, what the hell just happened? So I'm just gonna box this for the answer. Okay. Let's take a look at example 3. Let f of x to be 2x to the third, g of x equals 3x squared plus 2. Question is, find f of g evaluated at 1, g of f of 1, and g of g of 1. Now, there are two ways that you can compute this. So let me show you both ways, and you can pick and choose whichever method that you like to do. Okay, so let me just call this method 1. Okay, method 1 is actually to compute f of g of x, then plug that 1 into that resulting function. So first, let me just go with f of g of x first. Then after we compute that function, then we're going to replace x with 1. So first, let me just rewrite this as f of g of x. So we're going to do the same thing as before. So this is f of 3x squared plus 2. Now you better be looking at f of x now, and your job is to replace its x with what's in the parentheses. So here you're going to have 2 times 3x squared plus 2 to the third power. Now, since I didn't ask you to simplify it, leave your function the way it is. Now with this, so this is our f of g of x. So if I want to compute f of g of 1, what do you think we need to do? Well, we're going to have to replace the x with 1. So here what we're going to get is 2 of 3 times 1 squared plus 2 to the third power. So this is going to be 2 times 1 squared is 1. So we're going to have 3 plus 2 to the third. So this is 2 times 5 to the third, which is 2 times 5 to the third is 125. I'm running out of room. So 2 times 125 is 250. So here's one way to do it. But do you see that if you computed f of g of x, that function, to be a little bit off, meaning suppose you made a mistake on computing f of g of x, then do you see that f of g of 1 value is going to be off too? So here's the safer way to do it if you're not quite sure if your f of g of x is correct. So let me call this method 2. I'm going to call this the safe way. Okay, so first what we're going to do is this. Let me just write it out. F of g of x, g of 1, sorry. Okay, so let me write down the definition. So this is f of g of 1. Okay, so next step is this. Compute g of 1 first. Our g of x is 3x squared plus 2. So let me just work it as a side work. So I'm going to take this g of 1 and let's compute on the side. Our g of x is, again, I'll write it out, is 3x squared plus 2. That's a squared, sorry. So our g of 1 is going to be 3 times 1 squared plus 2, which is 5. So now, next step, this is going to equal to f of, well, we just computed g of 1 is 5. So I'm going to replace the g of 1 as 5. Now this is telling you, look at function f of x, replace its x with 5. So from here, since our let me see. Since our f of x is 2x to the third, our f of 5 is going to be 2 times 5 to the third. Does that make sense? So this is going to be 2 times 125, which is 250. But let me just go with it. So this is going to equal to f of 5, so which is what I just wrote, 2 times 5 to the third. Now, which gives us 2 times 125, and our answer is 250. So, hopefully, we better get the same answer by doing method 1 and method 2. I'm not sure which method that you like, but pick your favorite weapon. Okay, now let's go with a g of f of 1. I'm not quite sure which method that you like, but a lot of students like method 2, which is the safe way. So let me just compute it in that way. So here, oops. Let's go with g of f of 1. So again, we're going to do this the safe way. So here, let me rewrite g of f of 1. All right, now as a side work, first compute your f of 1. Okay, our f of x is 2x to the third. So that means f of 1 is 2 times 1 to the third, which is just 2. So I'm going to replace our f of 1 now with 2. Okay, so now this is telling you, look at function g of x replaces x with 2. So in this case, since our g of x is 3x squared plus 2, maybe I'll write everything out for you. G of x is 3x squared plus 2. That implies that g of 2 is 3 times 2 squared plus 2, which is, what is that? 3 times 4 plus 2. 3 times 4 is 12 plus 2 is 14. So that's how it's going to have to work. So let me just write. Now g of 2 is, again, 3 times 2 squared plus 2. So which is 3 times 4 plus 2, which is going to give us 12 plus 2, which is 14. Okay, now let's try g of 1. So again, I'm going to try to do this the safe way. G of 1. Let me rewrite. So this is g of 1. I know that we already computed g of 1 earlier, but let me just do it again, just in case you missed it. So let's go with g of 1, but our g of x is 3x squared plus 2. So g of 1 is 3 times 1 squared plus 2, which is 5. Okay, so now I'm going to replace our g of 1 with 5. Now this is telling us now that compute g of 5. So in place of x, we're going to replace that x with 5. So now what we're going to get here is 3 times 5 squared plus 2, which is 3 times 25 plus 2, which is, what is that, 75 plus 2. So our answer looks like it's going to be 77. Okay, now what we're going to do is we're going to talk about this thing called a one-to-one function. Let's recall that from the previous section, function is a relation such that for every x, there is exactly one y value. Now that function becomes a one-to-one function if for every y, there is exactly one x value. So your textbook defines one-to-one function in this way. A function is one-to-one if each value in the range corresponds to one element in the domain, i.e. for each ordered pair x, y, each y value is matched with only one x value. There are no repeated y values. Don't worry, we're going to do some examples. So let's take a look at something like this. Example 4. For each set of ordered pairs, determine if it represents a function, and if so, if the function is one-to-one. So let's go with part A. There are some serious amount of ordered pairs there. So how many ordered pairs? 1, 2, 3, 4, 5, 6, 7. But no big deal, we got this. So first, let me jot down all the values from the domain, which is -3, -2, -1, 0, 1, 2, 3. Okay, now let's go with the y values, which is the range. So range is -6, -4, -2, 0, 2, 4, and a 6. All right, let's try to match these guys up. So when x is -3, y is -6. When x is -2, it's going to go to -4. When it's -1, it's -2. 0 goes to 0. 1 goes to 2. 2 goes to 4. And then 3 goes to 6. So first of all, is this a function? For each x, is there exactly one y value? I believe in this case, yes, it is a function. So I'm just going to write it as, yes, this is a function. Because for each element of x, there's exactly one y value. Now, let's determine whether if this is a one-to-one function. Function is one-to-one if every y better have exactly one x value. So let's take a look at all the y values, which are -6, -4, and so forth. Does those guys have exactly one x value? I believe so, because when y is y is -6, it has exactly one x value, which will be -3. When y is -4, that guy goes to -2. When y is -2, it's going to go to -1, and so forth. So in this case, this is going to be a one-to-one function. So let me just write, in fact, this is 1-to-1 function. All right, now let's take a look at another example. Part B, given those ordered pairs, let's first determine whether this relation is going to become a function or not. Okay, I'm going to do the same thing for the domain. Those are all the x values. We have -3, -2, -1, 0, 1, 2, and a 3. Now the y values are 27, 8, 1, 0, 1, but I already wrote down 1 already, so I'm not going to write it. And then 8, I already wrote down 8, and 27. Okay, I already wrote 27. So I believe that our y values are 27, 8, 1, and a 0. All right, so let's play the same thing. So let's try to go from x to y. So from when x is -3, our y is 27, -2 goes to 8, -1 goes to 1, 0 goes to 0, cool, and 1 goes to 1. All right, and then 2 goes to 8. Can you see this okay? I'm sorry, it looks kind of ugly looking now. All right, and then 3 goes to 27. Okay, so now, does this relation define a function? I think it does, because for each x, there is exactly only y value. So this relation is a function. Now, what makes it not a function? So let's just take when x equals to 3. Now suppose that when x is 3, 3 is going to go to both 1 and 0 or something like that. Then that is not going to be a function. However, in this case, it is a function because for every x, there is exactly one y value. So I'm just going to write it as function. Function. All right, now let's determine whether this is going to be a one-to-one function or not. Again, in order to be a one-to-one function, for every y value, there better be exactly one x value. So let's take a look at when y equals to 27. Okay, so let me just circle this guy. Now, if it's one-to-one, 27 better have exactly one x value. However, let's look at this ordered pair and then this ordered pair. Notice that when y is 27, 27 is going to go to two x values, which will be -3 and a 3. So that violates the definition of being a one-to-one function. So let me just draw an arrow just like what I did for part A. So when y is 27, this guy is going to go to -3, and at the same time, this is going to go to +3. Therefore, it is not a one-to-one function, but it is still a function though. So let me just write it as not one-to-one function. Hopefully you can see the difference between the two, but again, if you have any questions, of course, please let me know. And now let's talk about this thing called the horizontal line test. Here comes the theorem. Horizontal line test. It says that if every horizontal line intersects the graph of a function in at most one point, it is a one-to-one function. Now, from the previous section, do you remember the vertical line test? Well, the vertical line test determines whether the graph is a function or not. And horizontal line test determines whether the function is one-to-one function or not. Let's do some examples. Example 5, determine whether each graph is the graph of a function. If so, whether it's a one-to-one function. Let's look at part A. So I just drew a parabola shifted how many units downward? 1, 2, 3, 4 units downward. But anyways, let's first determine whether this graph is a function or not. Well, if it's a function, it better pass the vertical line test. So does it? I think so, because anywhere you're going to chop this graph off, that vertical line is going to intersect the graph at only one point. So yes, this is a function, because you can say that it's a function because it passes the vertical line test. Now let's determine whether this is going to be a one-to-one function. According to the theorem, it says that the function it's going to become one-to-one if it passes the horizontal line test. What does it mean to pass the horizontal line test? So if you draw a horizontal line at anywhere along the graph, it better intersect the graph at most one point. So if it intersects at 2 points, it is not going to be a one-to-one function. So clearly, this is not going to be a one-to-one function, because if I just draw a horizontal line, like maybe right here, notice that the line intersects the graph at 2 points. So therefore, it fails the horizontal line test. So this is not going to be a one-to-one function. So function, but not one-to-one. Part B, now let's look at the graph that looks like this. So first of all, is this a function? Well, does it pass the vertical line test? I think so, because anywhere you're going to draw a vertical line, that line is going to intersect the graph at only one point. So this is a function. We say that it's a function because it passes the vertical line test. Now, does it pass the horizontal line test? Well, I think it does as well, because any horizontal line that you're going to draw along the graph, that horizontal line is going to intersect the graph at only one point. So in this case, it is a one-to-one function. So I'm going to put 1, 2, 1. Func means function. Now let's look at part C. Given that graph, let's determine whether that graph defines a function. If so, let's determine whether if it's one-to-one. All right, so what do you think? Is this a function? I don't think it is, because it fails the vertical line test. As you can see, if I draw a vertical line here, that line's going to intersect the graph at 2 points. So therefore, it fails the vertical line test. So this is not a function. Since it's not even a function, we cannot even talk about it being a one-to-one function. All right, our next topic is inverse of a function. So suppose we defined our function f of x to be f of x equals x plus 2. Now I'm going to pick some random values for x, so maybe -1, 0, 1, and 2. And our f of x is going to take all these x values to its range. So let's first compute f of negative 1. So I'm just going to write this on the side. So f of negative 1, this is going to give us negative 1 plus 2, which is 1. So this is going to go to 1. Now when x is 0, f of 0 is going to be 0 plus 2, which is just 2. So when x is 0, it's gonna, f of x is gonna take this value is 2, y equals to 2. Now when x equals to 1, f of 1 is gonna be 1 plus 2, which is 3. So when x is 1, it's gonna give us 3. And let's go one more. So when x is 2, we're gonna get 4. So 2 is gonna go to 4. So this is clearly, this is a one-to-one function. Now let's talk about the inverse of a function. Notice that our function f of x goes from the domain to range. Now the inverse of a function, we're gonna go the other way, meaning from the range to the domain. So basically, when y equals to 1, it's gonna go to negative 1. When y equals to 2, our x value is gonna be 0. Y equals to 3, x is 1. When y is 4, x is gonna be 2. So this is the function f inverse of x. That's the notation for that. That reads as f inverse of x. Please note that that negative 1 is just the notation. So I don't want you to get confused between these two. So if you had like maybe 2 to the negative 1, that was 1/2, wasn't it? But f to the negative 1, that does not equal to 1 over f, by the way. So be careful there. Anyways, notice that the domain of f inverse is the range of f of x. Do you see that? Because, let me see. For f of x, this is going to be the domain, and this is going to be the range. All right? However, f inverse of x is going to go the other way. So from f inverse's point of view, the range for f of x is going to become the domain of f inverse of x. And the range of f inverse of x is nothing but the domain of f of x. Let's first talk about inverse of a function defined by ordered pairs. It says that if f of x is a one-to-one function whose ordered pairs are of the form x comma y, then its inverse function, f inverse of x, is the set of all ordered pairs y comma x. The important part is this. In order for the inverse functions to exist, our f of x must be one-to-one, or else you cannot define an inverse function for f. Let's take an example. Example 6, find the inverse of those set of ordered pairs and find the domain and a range of f inverse of x. Okay, now let me jot down all the x values. We have 0, 1, 2, and a 5. And the corresponding y values are 4, 7, 9, and a negative 1. Well, first of all, is this a one-to-one function? Yes, it is. So let me just write it like this. Okay, so notice that the domain of f of x is 0, 1, 2, 5, and the range of f of x is 4, 7, 9, negative 1. Now remember, f inverse of x, it's going to go the other way. So instead of from left to right, we're going to go from right to left. So this is our function f inverse of x. Okay, so notice that again, the domain of f inverse of x is nothing but the range of f of x. And the range for f inverse of x is nothing but the domain of f of x. But first, let's just write down the inverse of those ordered pairs. Now the inverse of ordered pairs, let me just write it. You just swap the x and the y values. So here you're going to have 4, 0, 7, 1, 9, 2, negative 1, and a 5. All right, now let's go with the domain of f inverse of x. So that's just my notation for domain of f inverse. Now the domain of f inverse is nothing but the range of f of x. So let me just write, so this is the domain of f, and this is the range of f. But that's same thing as domain of f inverse, and then this is going to be the range of f inverse. Keep that in mind. All right, so the domain of f inverse, those values are 4, 7, 9, and negative 1. And the range of f inverse, this is going to be 0, 1, 2, and a 5. All right, so that's our answer. Let's take a look at example 7. Given this graph, what we want to do is graph the inverse of this one-to-one function. So remember that inverse function, your ordered pair is going to swap around. So let's go from 4, 5. Now that's going to go to, that's going to go to 5, 4. Okay, now let's go with 2, 1. This is going to go to 1, 2. All right, now who's next? 1, 0. 1, 0 is going to go to 0, 1. And then negative 1, negative 2. This is going to go to negative 2, negative 1. Then negative 5, negative 4. Now this is going to go to negative 4 and negative 5. So I'm just going to jot those points down. So 5, 4. 1, 2, 3, 4. All right, now let's go with 1, 2. So this is 1, 2. 0, 1, 0, 1 will be right here. And then negative 2, negative 1 is right here. And then negative 4, negative 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right, so this is, ooh, I'm running out of room here. So this guy right here is negative 4, negative 5. So it looks like our graph's going to look something like this. I am the worst at graphing. Here we go. There. All right. So this is the graph of f inverse of x. Okay, now since we already talked about the inverse of an ordered pairs and then inverse in terms of a graph, now we're going to have to find the inverse functions algebraically. But before we get into it, let's go with the theorem of inverse functions. So here's the theorem. If f and f inverse are truly the inverses of each other, then this needs to happen. F inverse of f of x must equal to x, and f of f inverse of x equals to x. You need to check both. Don't worry. Again, we're going to do some examples. So example 8, determine whether given functions are inverses or not. So here we have f of x equals x minus 9 and g of x equals to x plus 9. Are they inverses of each other? Well, how do you check? What we need to do is, if f and g are inverses of each other, then f of g of x must equal to x, and then g of f of x must equal to x. So don't worry, I'll write everything out. So what we need to check is f of g of x, does it equal to x? And after that, you need to check g of f of x, is it going to equal to x? If both are true, then f and g are truly inverses of each other. If one side fails, then they're not inverses of each other. So let's get to work then. So let's first check, is f of g of x, is it gonna equal to x? All right, so let's do it. F of g of x, so this is f of x plus 9. So now what we need to do is, remember, you're gonna have to plug x plus 9 into a place of x under f of x. So here what we're gonna get is x plus 9 and then minus 9, which gives us x plus 9 minus 9, which is x. All right, so far so good. Now let's check, is g of f of x, is it gonna equal to x? All right, let's check g of f of x. So this is gonna be g of x minus 9. That's a 9, sorry. All right, now you're gonna have to plug in a whole quantity x minus 9 in place of x under g of x. So here you're gonna have x minus 9 and then plus 9. So this is x minus 9 plus 9, which gives us x. Yay! So therefore, remember this 3 dots in triangle means therefore, f and g are inverses of each other. Okay, so that's what we need to do. And let's take a look at more examples. Next one, let's go with f of x equals x over 12 and g of x equals 12x. So what we need to check first is f of g of x. So let's go. So f of 12x, which is going to give us 12x over 12. Kill the 12s. Sorry, let me just do this. So what we have left with is just x. Looking good. All right, now the other way. We need to check g of f of x. All right, so here you're going to have g of f of x is x over 12. So what we need to do is we need to plug it in x over 12 in place of x of g of x. So here you're going to have 12 times x over 12. Is it looking good? I think so. So this is going to give us x. Yay! So therefore, f and g are inverses of each other. All right. How you guys doing up to here? All right, so let's do a couple more. Let's build our ways up. So let's look at part C. Let's look at f of x equals 7x plus 3 and g of x equals x minus 3 whole thing over 7. Okay, ready? So check f of g of x. So we got f of g of x is x minus 3 whole thing over 7. So this is same thing as 7 times x minus 3 over 7 and then plus 3. All right, now 7 is same thing as 7 over 1, so look what happens. Since you're multiplying 7 times the whole quantity x minus 3 over 7, you could kill the 7. So what's left over? Looks like we're going to have x minus 3 and then plus 3, which gives us x. Looking fantastic. Now let's go with check. G of f of x. All right, we got this. So g of f of x is 7x plus 3. All right, so g of x is defined as x minus 3 over 7. So this expression is going to look like 7x plus 3 minus 3 whole entire thing dividing by 7. Okay, so this is same thing as 7x plus 3 minus 3 all over 7. This is going to cancel out. So this is going to give us 7x over 7. Kill the 7, kill the 7. And fabulous. It's going to equal to x. So therefore, f and g are inverses of each other. So there we have it. Let's do another one. So f of x equals fifth root of x minus 4, and g of x equals x to the fifth plus 4. All right, check. F of g of x. So what do we got? We have f of x to the fifth plus 4. All right, so it looks like we're going to have fifth root of x to the fifth plus 4 and then minus 4. All right, so this is going to be fifth root of x to the fifth plus 4 and then minus 4. I'm trying to do everything step by step here. So this is going to cancel out. So what do we get? Fifth root of x to the fifth. So this is going to give us x. All right, now let's check the other way. G of f of x. So we got g of f of x is fifth root of x minus 4. So that's same thing as, all right, g of x is what? X to the fifth plus 4. So it looks like we're going to have fifth root of x minus 4 to the fifth power and then plus 4. Now, fifth root and fifth power sort of cancels each other out. So what we're left with is x minus 4 and then plus 4, which gives us x. So again, we can conclude that f and g are inverses of each other. All right, and here's our answer. Okay, so finally, our next topic is, given f of x, how do we find the inverse function of that? And of course, given function must be a one-to-one function. Here are the steps. So here are the steps. So step number 1, let y equals to f of x. Step 2, interchange the roles of x and y. Step 3, solve for y. Now, if you cannot solve for y, then f of x does not have its inverse. Step 4, rewrite the new y as f inverse of x. And lastly, check, is f of f inverse of x, does it equal to x? And does f inverse of f of x, is it going to equal to x? And if so, then they are truly inverse functions of each other. Okay, let's take a look at an example. Example 9, find the inverse function. So don't worry, we're going to go over a few examples. We're going to build our ways up. So let's go nice and easy first. Let f of x be negative 4x minus 3. Okay, so step number 1, I'm just going to write it as circle 1. Let y equals f of x. So y equals to negative 4x and then minus 3. All right, now step number 2, interchange the roles of x and y. So y is going to become x, and then x is going to become y. All right, now step 3, solve for that new y. Okay, so how do I solve for y? Well, I need to probably add 3 on both sides. So here what we're going to get is x plus 3 equals negative 4y. All right, now let's keep solving for this. Next step is what? Dividing by negative 4. So let me see, dividing by negative 4. Now, you can divide the whole entire thing by negative 4, or you can just do this. Hold on. Divide each term by negative 4. So this is same thing as over negative 4 and then over negative 4. So either way, if I solve for y, we're going to have x plus 3 whole thing over negative 4. Since we're able to solve for y, let's claim that this is going to be our f inverse of x. So I'm going to claim that f inverse of x is going to be x plus 3 whole thing divided by negative 4. All right, let me just box f inverse of x and then f of x because we need to check next. All right, now here comes the hard part. We need to check to make sure that f and f inverses are truly inverses of each other. So check, doesn't matter which way you do it first, but let me just go with f of f inverse of x. So here you're going to have f of x plus 3 whole thing dividing by negative 4. So let's look at function f. and I'm going to replace its x with what's in the parentheses. So here you're going to have negative 4 times x plus 3 whole thing over negative 4, and then minus the 3. Alright, so since negative 4 same thing as negative 4 over 1, notice that I can cancel out the negative 4's. And here what we're going to get is just x plus 3 minus 3, which just gives us x. Looking good. Alright, now let's look at the other way. Check. F inverse of f of x. Alright, so we got f inverse of f of x is negative 4x minus 3. So let's look at f inverse of x, and then let's replace its x with what's in the parentheses. So here what we're going to get is negative 4x minus 3, then plus 3, whole thing dividing by negative 4. So let's simplify the numerator. So here you're going to have negative 4x minus 3 plus 3, whole thing over negative 4. So this is going to cancel. So we got negative 4x over negative 4. Cancel the negative 4's, and we have the x back. So therefore, our f inverse of x is truly x plus 3 whole thing dividing by negative 4. Alright, let's take a look at the next example. Again, we're going to build our ways up, so I'm going to try to make it a little bit more difficult as we go along. Alright, so we got f of x to be x squared plus 6, where x is greater or equal to 0. So remember step number 1, let y equals f of x. And don't forget this condition as well. Always write down the condition as well. Now step 2, interchange the roles of x and y. So we have x equals y squared plus 6. Now don't forget to change this guy. Y is greater or equal to 0. Alright, now let's try to solve for y. Okay, we're going to have to be careful a little bit here. So first, we're going to have to subtract 6 from both sides. Then we're going to have x minus 6 equals to y squared. Or same thing as y squared equals to x minus 6. Alright, now be careful. When you take the square root on y squared, you're going to have a positive side of square root of x minus 6 and the negative side of the square root of x minus 6. So meaning this, if I take the square root of it, let me just copy and paste the same problem. So if I take the square root, next step, what we're going to get is our y is not just square root of x minus 6. We're going to have y equals to positive square root of x minus 6, or y equals to negative square root of x minus 6. Alright, so be careful right there. And I forgot to write down the condition. So condition was y better be greater or equal to 0. Now let's analyze for a bit. Which function is going to give our y value to be greater or equal to 0? Well, I think it's this one. Because look at the bottom one. The bottom one is what? Y equals negative of something. So here, what we need to do is this. For step number 4, you can only pick one function, which will be y equals to square root of x minus 6. So we're going to call this guy f inverse of x. Alright, so let me just box this. And let's box our f of x as well, because we are about to check. Oops, I'm just going to include this guy as well. Alright, so let's do it. Step 5, check. F of f inverse of x. So this is f of square root of x minus 6. So this is going to be f of x is x squared plus 6. So you're going to have to replace that x with square root of x minus 6. So we're going to have square root of x minus 6 squared and then plus 6. So in this case, square root and then the power of 2, they're going to cancel each other out. So here you're going to have x minus 6 and then plus 6. So it's going to give us x. Now check the other way. F inverse of f of x. So here you're going to get f inverse of f of x is x squared plus 6. All right, so f inverse is square root of x minus 6. So we're going to have square root of x squared plus 6 and then minus 6. All right, so is it going to work out nicely? So here you're going to have square root of x squared plus 6 minus 6. So this is going to give us square root of just x squared because those 6 is going to cancel each other out, right? So kill, kill. And then now what? So this is going to give us, by the way, square root of x squared, by definition, this is going to give us an absolute value of x. But notice that our condition for f of x was x was greater or equal to 0. That's why you can drop that absolute value and let's just call this guy x. Sorry if that was kind of confusing, but square root of x squared, we're just going to call that guy x. So therefore, our f inverse of x is truly square root of x minus 6. All right, so let's go a couple more. Hang in there. So part C, let's go with f of x equals 1 over x minus 5. All right, step 1, let y be 1 over x minus 5. Step 2, change it up. We're going to have x equals 1 over y minus 5. All right, next step, we're going to have to solve for y. So here's one way to do it. You can multiply both sides by the LCD, which will be y minus 5. Or you can think of it as cross multiplication. It means the same thing, but let me see. Let me just do this formally. Oops. So here what I'm going to do is multiply here by y minus 5. That means I'm going to multiply here by, oh no, y minus the 5. All right, so let me just write it down nice and pretty. So what I just wrote was y minus 5 times x equals 1 over y minus 5, and then I multiplied here by y minus 5. Okay. All right, so then what are we going to get? This is going to cancel out. And this x, I need to distribute this to each term. So here what we're going to get is xy minus the 5x equals to 1. So far so good? All right, so now what? Now we need to solve for y. So first, let's get rid of that negative 5x by adding 5x on both sides. So here's what I'm going to do. All right, so if I do that, I'm going to have x times y equals 1 plus 5x. All right, so now how do you solve for y? Divide this guy by x, dividing this guy by x. Now, for this particular problem, it might be easier, instead of writing it as y equals 1 plus 5x over x, try to rewrite this as 1 over x plus 5x over x. We can definitely do that. So this is 1 over x plus 5. Do you see why I did that? Because if I claim this guy to be f inverse of x, notice that if I chose the first guy right here, we have 2 places for x. So we're going to have to plug it in more x values than necessary. Whereas if I simplify that a little bit, this guy right here, this expression, that guy only has 1 x. So to me, I have a feeling that might be a lot simpler to compute the f of f inverse of x and vice versa. So I'm going to write our f inverse of x as 1 over x and then plus 5. All right, now let me box f of x and f inverse of x. All right, now here comes the check. So let's first go with f of f inverse of x. So we got f of 1 over x plus 5. So here, let's see, f of x is 1 over x minus 5. So it looks like we're going to get 1 over x plus 5 and then minus the 5. So this is going to be 1 over x plus 5 minus 5. So this is 1 over x. Now remember, this is same thing as 1 dividing by 1 over x, isn't it? So this is same thing as 1 dividing by 1 over x, but 1 is 1 over 1. So do you remember how to make that in a multiplication? So you're going to have 1 over 1 times x over 1. So here, what we're going to get is just the x back. All right, now let's check the other way. F inverse of f of x. All right, we got this hanging there. So f inverse of x is 1 over x plus 5. And let me just write down the f of x first. F of x is 1 over x minus 5. So let's replace x for f inverse of x with what's in the parentheses. So you're going to have 1 over x minus 5 and then plus 5. Okay, so now we're going to do the same thing. So let me see. So this guy right here is same thing as 1 divided by 1 over x minus 5, isn't it? So let me write it out. So I'll spell everything out. That's same thing as 1 divided by 1 over x minus 5 and then plus 5. So which turns into 1 over 1. So 1 times x minus 5 whole thing over 1 and then plus the 5, which gives us x minus 5 and then plus 5. Boom, it's gonna equal to x. So therefore we just verify that this is truly our inverse function for f of x. Okay, I promise this will be the last example that we're gonna go over. So let's do it. So f of x is given to be 4th root of 8x minus 3, where x is going to be greater or equal to 3 over 8. Again, you're given the restrictions here. So let's do it. Step 1, let y equals to f of x. All right, step 2, interchange the roles of x and a y. Don't forget the condition. So here you're going to have y is greater or equal to 3 over 8. All right, now step 3, solve for y. Well, how are we going to solve for y? Y is trapped under the 4th root. So first we need to get rid of that 4th root. Who's going to kill it? It's the 4th power. Going to raise the right-hand side of the equation by 4. That means we're going to do the same thing on the left-hand side of the equation. So right now we have x to the 4th equals 8y minus 3, where y is greater or equal to 3 over 8. All right, solving for y, first let's add 3 to both sides. So you get x to the 4th plus 3 equals to 8y, where y is greater or equal to 3 over 8. All right, now divide everything by 8. So then what we're going to get is x to the 4th plus 3 all over 8 equals to y, where y is greater or equal to 3 over 8. Okay, so step 4, let's call this guy f inverse of x because we're able to solve for y. So our claim is that f inverse of x is going to be x to the 4th plus 3 whole thing dividing by 8, where f inverse of x value must be greater or equal to 3 over 8. All right, so keep that in mind. So here our f inverse of x values must be greater or equal to 3 over 8. All right, so let me just box this. And here comes the hard part. We're gonna check. All right, so let's check f of f inverse of x. So here, let's see. We get f of x to the 4th plus 3 whole thing over 8. And, oops, I forgot to box the f of x. So this is our f of x. And I should have mentioned this from the very beginning. Do you see why x must be greater or equal to 3 over 8? Because of that's because of the domain restriction for the 4th root of x. Because remember, eventh root, if we have a square root, 4th root, 6th root, you can only have the value that's going to be greater or equal to 0. meaning fourth root of a negative number is undefined. So if I choose some value of x that's gonna be less than 3 over 8, what's less than 3 over 8? Maybe 0. So if I pick x equals to 0, and if I plug that into f of x, what we're gonna get is fourth root of, let me just write this out. If I do that, then we're gonna have, when x is 0, we get fourth root of 8x minus 3 is going to become 8 times 0 minus 3. So what you got? You got fourth root of a negative number, which becomes undefined. So this is just telling you that in order for this function to be defined, all the values of x must be greater or equal to 3 over 8. That's all. All right, but anyways, let's go back to what we're doing. So right now we're computing f of f inverse of x. So that's same thing as f of x to the fourth plus 3 over 8. Okay, so now let's look at function f. So you're going to have fourth root of 8 times x to the fourth plus 3 over 8, and then minus 3. Whole thing is inside of the radical. So now 8 is same thing as 8 over 1, so we could cancel that. So this is fourth root of x to the fourth plus 3, and then minus 3. So this is going to give us fourth root of x to the fourth. So this is going to give us our x back. All right. Now let's go the other way. F inverse of f of x. So we got f inverse of f of x is fourth root of 8x minus 3. All right, f inverse of x. Okay, so I'm going to replace that x with fourth root of 8x minus 3 to the fourth power plus 3, whole thing dividing by 8. All right, so what do we get? Fourth root and fourth power is going to cancel each other out, so we got 8x minus 3, then plus 3, whole thing dividing by 8. Kill the 3's. And then what we got is 8x over x. Now kill the 8, then this is gonna equal to x. Phew! How was that one? Alright, so therefore our f inverse of x is truly x to the fourth plus 3 all over 8. I'm going to stop right here and stop torturing you. I know that the composition of function, at first, it's not the easiest. I had the difficult time trying to learn composition of functions when I was going to school. But anyways, great job. If you watch this whole thing till this last example, you are freaking awesome. But anyways, great job. And if you have any questions, please let me know.